Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. It's not enough to build a network and deploy it. There needs to be ongoing monitoring of the network so that you can troubleshoot issues as they occur and optimize the network over time. SNMP is a network management protocol for TCP/IP networks, and it consists of three different things: managed devices, an SNMP manager, and SNMP agents. An SNMP manager, which is sometimes called the Network Management System or the NMS, is responsible for requesting and processing information that agent software installed on managed devices provides it. Managed devices includes basically any kind of device on your network, like printers, computers, video cameras, routers, and more, but you get the idea. SNMP is considered an extensible protocol, so it can be adapted to collect different information. SNMP uses Management Information Bases, or MIBs, to categorize the information that it collects, and each individual entry is called an Object Identifier, or an OID. When it comes to functions, SNMP has 8 core functions, which are also called Protocol Data Units, or PDUs, but there are 4 that you need to know right now: Get, Response, Set, and Trap. The SNMP process works like this. If an SNMP manager needs to query an agent, it'll send a GET request like GET request or GET next request. An agent will then send back a response with whatever information was requested. If an SNMP NMS wants to make a change, it can send a SET request to that agent, and it includes variables of what needs to change in that information. If an agent wants to get information from the NMS, it can send a trap PDU. Make sure that you remember that SNMP manager sends GET requests to retrieve information, and that the agent sends traps if it needs to provide information like a status without the NMS prompting it to do so. SNMP managers have a capability called event management that allows them to send alerts to people via email, SMS, or whatever way is available if needed. If you want to see what's in the MIB, SNMP Walk is a useful tool on macOS and Linux that allows you to query SNMP devices from a terminal window. There's 3 different versions of SNMP that you need to know about. We have SNMP version 1, which was originally released in 1988. Then we had SNMP version 2C, which tweaked version 1 slightly. And then we have SNMP version 3, which adds extra security, including encryption support and authentication. SNMP uses UDP ports 161 for the agent to listen and receive, and UDP port 162 for the NMS to listen and receive. If Transport Layer Security, or TLS, is added to SNMP for security, which we also sometimes call Secure SNMP, then it uses port 10,161 for the agent and 10,162 for the NMS. All of these ports are defined by RFC 6353. You'd be surprised how much data actually goes through a network. It can be pretty challenging to sort through all this data and actually make sense of it. But when it comes down to it, there's 4 different types of monitoring tools that we need to talk about. We have packet sniffers, protocol analyzers, interface monitors, and performance monitors. Packet sniffers are a piece of software that collects packets from a network interface and stores the information into a file called a capture file. One of the key things that a packet sniffer needs is the ability for the network interface to enable promiscuous mode so that it can see all the traffic on the network instead of just the traffic that's destined for that local interface. On switches, you can also use something called a mirrored port, which sends a copy of all the packets going through that switch to that mirrored port, which will then have a tool connected to the port. Usually, packet sniffer functionality is combined with a protocol analyzer tool to actually look at the packets. If it was just a packet sniffer tool, then it would only collect the packets. Protocol analyzers, which are also sometimes called packet analyzers, are a program that takes packet capture files and allows us to analyze them. These tools allow you to filter packets based on specific requirements so that you can see the data that you want to see. A very common protocol analyzer is a tool called Wireshark. Let's take a look at Wireshark, and then we'll talk a little bit more about the data that you can collect. NetFlow is a Cisco-developed product that allows for packet flow monitoring, and it's included with their routers and switches. You'll need to define the type of traffic that you want to see, which comes as NetFlow data, which enables administrators to build a clearer picture of the volume and flow of traffic on the network. NetFlow uses something called a NetFlow collector to store information from one or more devices that NetFlow caches so that it can be analyzed by NetFlow analyzers, which many companies, including third-party companies, develop these types of tools. It's not uncommon to have sensors around your organization. Environmental sensors to detect temperature, physical flooding, and humidity levels, but also device or chassis sensors on racks of equipment or systems themselves are quite common. Network metrics are also important for bandwidth use, like latency and jitter, but there's much more. Interface monitors allow you to track the bandwidth and utilization of interfaces on one or more devices. They allow you to see how hard the interface is working, and they can help you with monitoring traffic on the network. Zabbix is a graphical tool option for interface monitoring, and then devices like those from Cisco have command line show commands that will provide interface information. Performance monitors allow you to track the performance of some aspect of a system. Usually these are built into the operating system or at least tied to its operation because of the information that they need to access. Windows has a tool called perfmon.exe, and macOS and Linux have a tool called syslog that will allow you to monitor performance. In case it ever comes up, syslog's default destination port is UDP port 514, and it can generate messages based on their severity level from 0 for emergencies, like the system is down, all the way up to 7 for debug messages that are used in debugging a program. Performance monitors utilize system logs to help track performance over time. Perfmon will refer to these as counters, and syslog will call them facilities. It's crucial that configuring logging is part of the setup process for any new devices so that something doesn't happen and you find yourself without logs. Log management is also important because you need to keep the logs protected for security reasons due to what they can contain, but you also need to plan for how much memory they take up. Some of these log files can get extremely large, and if you're not careful, a system might crash because the log file is too big. With that being said, cycling logs refers to deleting the oldest log as new entries come in, or sometimes you'll see logs saved off to another location and then reset at regular intervals like daily, weekly, or monthly. Even after all that, only keep the logs that you need for as long as you're required to keep them. You can sometimes refer to regulations or laws that will actually identify the retention period. If you aren't sure, ask your legal department. Baselines establish a normal state or performance level, and that way if things drastically change, you can identify issues quicker and easier. Another key topic with regards to performance monitors is baselines. Baselines establish a normal state or performance level, and that way if things drastically change, you can identify issues quicker and easier. iPerf is another tool that can help you with performance monitoring, and it can actively measure the available and the maximum bandwidth on a network. Security information and event management, or SIEM tools, aren't covered that much until security certifications, but these are another useful tool that allows you to monitor and manage your network in one central tool. These are really popular in cybersecurity, but you can get both security event management, SEM, and security information management, SIM, process information. File integrity monitoring, or FIM, is another common use for SIM tools where you can see if key files, like the log files, are modified in any way. These tools will also sometimes have the ability to get performance data and other information. Sometimes the monitoring of a SIM tool is outsourced to a managed security service provider, an MSSP, or your internal security team will handle it. A popular SIM tool that you might hear about or see or get to use is Splunk.